Hi guys, so in this video I'm going to be explaining solids and alloys as well as briefly going over the properties of liquids. So there are four kinds of solids that we need to know: metallic, network, ionic, and molecular solids. We'll start with metallic solids. Metals consist of cations embedded in a sea of delocalized electrons. So the structure of a metal is going to look somewhat like this: layers of cations embedded in a sea of delocalized electrons. The gray circles are the cations obviously, and the orange circles are the electrons. The metallic bond is a strong electrostatic force of attraction between the cations and the electrons. This bond is strong, so metals usually have a high melting point. Because of these delocalized electrons, metals have a few properties that make them special. We'll go over them. First is electrical conductivity. The delocalized electrons can move across the structure carrying charge, so metals can conduct electricity. The second is thermal conductivity. The delocalized electrons again can move across the structure rapidly, carrying thermal energy, meaning that metals can conduct heat. The third is that metals are malleable and ductile. Malleable means that you can hammer them into thin sheets, and ductile means that you can roll them into thin wires. This is because of the metallic bonds that are non-directional and can rearrange, so the layers of cations can slide across each other freely. The fourth and final property we're going to be going over is the fact that they are lustrous or emit a shine, and this is because electrons absorb the light and re-emit the light in the form of a shine. So, the next kind of solid is network solids. Network solids are giant structures with atoms bonded together in a continuous network throughout the solid. So network solids don't have molecules. You can think of the whole structure as one giant molecules of a lot of atoms bonded together with strong covalent bonds. And because the bonds are very strong, the melting point of network solids is usually very high, higher than metals and ionic compounds. There are three network solids we need to know: diamond, graphite, and SiO2. Diamond and graphite are both different arrangements of carbon. We'll start with diamond. Each carbon atom is bonded covalently to four other carbon atoms. All bonds are localized, which makes diamond extremely hard, the hardest substance known to man, but there are also no delocalized electrons, and because of this, diamond does not conduct electricity. Since each carbon is bonded to four other carbons, it's a tetrahedral structure, as you can see here. This is kind of a demonstration, a representation, sorry. The bond angle is 109 degrees and 4 electron regions, so sp3 hybrid orbitals. Next, we're going to go over graphite. So in graphite, each carbon atom is covalently bonded to three others, leaving one free electron, and because of these free electrons left over, graphite can conduct electricity and heat. It is a layered structure, which means that it consists of a lot of layers of carbon atoms bonded together, and these layers are attracted together with weak LDF forces of attraction. So as you can see, this is the structure of graphite. You can see that each carbon is bonded to three other carbons, triangular planar shape, 120-degree bond angle, sp2 hybrid orbitals, and these layers are attracted together with weak LDF, which means that they can slide across easily. SiO2, each silicon atom is bonded to four oxygens, and each oxygen atom is bonded to two Si. So you might ask, why do we write it as SiO2 and not Si2O4? That's because SiO2 is the simplest form of the ratio of silicon atoms to oxygen atoms, which is 1 to 2, so SiO2. So next kind of solid is ionic solid, and an ionic solid is formed when a metal bonds with a non-metal. An ionic bond is an electrostatic force of attraction between the cations and the anions in the structure. The strength of the bond depends on the charge of the ions and their size, so you can find the strength of the ionic bond with this formula. You can see, according to Coulomb's law, that it is directly proportional to the charges and inversely proportional to the square of the size of the ions. So ionic solids are poor conductors in the solid state, they're good conductors in the liquid or molten, and the aqueous state only. That's because in those states they dissociate into ions, and those can conduct electricity, but they can't conduct electricity in the solid state. They have high melting points because the ionic bond is strong, and they are hard and brittle and have a crystalline lattice structure. And finally, molecular solids. The structure of a molecular solid is different from the three because it is made up of molecules that are held together with IMF instead of ionic bonds or covalent bonds or metallic bonds. So a molecular solid is made up of molecules held together by IMF. This can be LDF, dipole, dipole, and H bonds. This structure is maintained by the IMF. So examples being I2, iodine, and dry ice, which is CO2 in the solid state. So now we're going to go over the types of alloys. First, an alloy is a mixture of a metal and one or more other elements. These elements can be a metal or non-metal or both. For example, stainless steel is an alloy of iron, chromium, nickel, carbon, and a few other elements. So there are two types of alloys, interstitial and substitutional. In a substitutional alloy, the two or more elements that are forming an alloy are of similar size, the the atoms of the second element replace the atoms of the first element as seen here. And in an interstitial alloy, the size of the atoms of the different elements do differ in size quite a bit. So the smaller atoms are going to be like put in between the bigger atoms. So it's going to look something like this. So now we're going to go over properties of liquids. So we have boiling point and vapor pressure. They both depend on the IMF. So a boiling point, if you have stronger IMF holding together the molecules of a liquid, you're going to have a higher boiling point. And vapor pressure is defined as the pressure of the vapor above a liquid in a closed container at equilibrium. So as you know, liquids aren't just staying the same constantly, they're constantly evaporating and they're also condensing. So at equilibrium, when these two rates become equal, the vapor that is above the liquid has a certain pressure, and that's the vapor pressure. This depends, of course, on the boiling point. A higher boiling point means at the same temperature, a liquid is going to have a lower vapor pressure than a liquid with a lower boiling point, which is going to have a higher vapor pressure at the same temperature. Vapor pressure depends on temperature and boiling point only. It does not depend on the size of the container holding the liquid. Keep that in mind. So, weaker IMF means lower boiling point means higher vapor pressure. Thank you. And an ionic solid and an okay, sorry, chemo, cut that out. An ionic bond. Okay, three, two, one.